All right, for this video, it'll be short and sweet, and we want to see if we can write the equations of a polynomial through if we're already given the graph. So what this will look like is you will first want to find all of the x-intercepts. And again, that's just where the graph either crosses or bounces off the x-axis. So for example 6 here, you can see we have a -3 and a +2. So the first thing you want to do is find the x-intercepts with the behavior. And it looks like these are both crossing x-intercepts. Bouncing x-intercepts. Bounce and bounce. So why is that important? Well, the next step is to, we'll say, create the factors. And to create the factors, it's basically what factor would you need in order to set it equal to 0, and when you solve it, you get -3. Well, it would be like saying we know this. If we want to set this equation equal to 0, I could just add 3 to both sides. And this is now my factor. So I have a factor of x plus 3. I also have an x-intercept of 2, which means my factor would be x minus 2. That's how I would get my equal 0. So there's my factor. The next thing we can do is come up here and start writing the function. F of x equals, leave a little bit of space here, and I'll come back to that in a second. We write down our factors. And now the third thing we need is to know what exponent goes on those factors. Well, we can figure that out if we know the behaviors. Oh look, we wrote them right here. So with the behaviors, a bouncing behavior just means that we have an even exponent on that factor, an even multiplicity. So bouncing means we will just use 2. You could use any even number as long as it's positive. It could be 4. You could put x plus 3 to the 100 power if you wanted. But 2 is generally the easiest to work with. Now, the very last thing that we need is for the sign for the leading coefficient. And for that, we just look at the right side of the graph, the right end behavior of the graph. And since this is going up, our leading coefficient will be positive, so it's just going to be a positive. And that's it. There's the answer. So now we can do something very similar over here, but a little bit quicker. We can take this x-intercept, and this x-intercept. So I know this is a -5, so that means I'll have an x plus 5. This is a +1, so I'll have an x minus 1. This is a +6, so I'll have an x minus 6. And this is a bounce, this is a cross, and this is a cross. So when I come up here to write the function, f of x, again, I'm going to leave this little space here for the sign. I will have an x plus 5, and I know that will be squared because it bounces at that particular x-intercept right here. And bouncing means even multiplicity. The other two factors here, x minus 1 and x minus 6, are in fact going to have exponents of 1. And so I'm not even going to write them, right? If a graph, a polynomial crosses the x-axis at an x-intercept, that means the multiplicity is odd. So we just use 1. Again, you could use 3 or 5 or 417, but 1 is going to be the easiest. Now, for that end behavior, here we go. We just look at the right side in behavior. The right side is going down. That means we will have a negative leading coefficient, so I'll put a negative here. And truthfully, we don't need to have these little underlines here. I just put them there so you knew to leave a little gap. There are another couple quick examples on the next slide. When it flips over, go ahead, pause it, try them for yourself, and then I'll come back with some answers. So here's the answer for example 8. And also, I have not said yet, but you want to make sure, since we are writing the equation of a function, that you have to have some sort of function notation over here and an equal sign. If all you give me is this little bit here, you are going to be in some big trouble. It has to have all of this equation, the function and the equal sign. So here we have an x-intercept of 3 that crosses the factor, the corresponding factor that would be x minus 3. If you set that equal to 0 and solve for x, you'll get 3. So similarly here we have 6, the factor is x minus 6, and it bounces there. So crossing, exponent 1, bouncing, exponent 2, and then since the right in behavior is going down, this is a negative leading coefficient. So really quickly here with the last one, we have 3 x-intercepts, as you can see. The leftmost x-intercept, aka the most negative x-intercept, is negative 3 with a corresponding factor of x plus 3. There it is in my function. This one is 0. We have an x-intercept x equals 0. That becomes the factor. It's x. And at positive 2, we have another x-intercept, so the factor that corresponds with it would be x minus 2. Now, the exponents here, anytime we have a bounce, that means we have an even multiplicity, which means we have an even exponent. So x plus 3 will be squared, x minus 2 will be squared, but this is a cross here, so the x factor will just have an exponent 1. Now for the end behavior for the leading coefficient, the right side is going up, which means our leading coefficient will be positive, and I can hear everybody. Do we have to put the positive in front if it's a positive leading coefficient? No, but it does let me know that you fully understand what's going on. So if you put it there, cool. If not, no big deal. I hope that helps. Good luck, everybody.